Good morning, dear students. Welcome back to physics class. Today, I would like to present mainly two topics. First one is accuracy and precision of instruments, and second one is errors in measurement, part A. For today class, at first I present the topic for you. The topic is accuracy and precision of measurement of a physical quantity. You know that measurement is essential for us to understand the external world and through millions of years of life. We have developed a sense of measurement. Measurements require tools that provide scientists with a quantity. The problem here is that the result of every measurement by any measuring instrument contains some uncertainty. Any uncertainty resulting from this measurement by using a measuring device is called error. You have to know that every measurement should have error, because there is no any ideal device developed so far to produce result with zero uncertainty. To understand the difference between accuracy and precision of a measurement, let me give you one situation now. Suppose you have done a set of measurements of a physical quantity. You have measured your height using a measuring tape, which were done by 6 or 7 trials more. From this set of measurements, accuracy is the closeness of the measurement you have done to a specific value, while precision is the closeness of the measurements to each other. That is, the accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity, and precision tells us to what resolution or limit the quantity is measured. I shall take account for these subjects again for your more understanding by giving another situation. For example, suppose you know true value of diameter of a sphere. It is near 2.978 centimeter. In your measurement by using a measuring instrument of resolution 0.1 centimeter, here the measuring device may be a ordinary scale with a least count which is equal to 0.1 centimeter or 1 millimeter. The measured value is found to be 2.8 centimeter, while in another experiment using a measuring device of greater resolution, say 0.01 centimeter, the instrument may be vernier calipers whose least count is 0.01 centimeter. The diameter is determined to be 2.58 centimeter. The first measurement has more accuracy because it is closer to the true value, but less precision. Its resolution is only 0.1 centimeter compared to the second one. But in the case of second measurement, which is less accurate but more precise. I repeat again, accuracy of a measurement is how close the measured value is to the true value, and precision is the resolution or closeness of a series of measurements of a same quantity under similar conditions. Now, I am going to teach you the specialized part, errors in measurement, some more deeply, and their classification. You understood that every result is approximate value to the true value, or real value due to errors in measurement. In general, the errors in measurement can be broadly classified into two types. First one is systematic errors and second one is random errors. First kind of errors are the systematic errors, which can occur either in be positive or be negative directions. It means that they are in unidirection. That is, their signs will be either positive or negative, and their sizes will be either in increasing or decreasing order. These errors tend to be in one direction. They can be classified into three types. First one is instrumental errors. Second one is errors due to imperfection in experimental techniques or procedure. And third one is personal errors. First one is instrumental errors. They are the errors due to imperfect design or calibration of the measuring instrument, zero error in the instrument, etc. I shall explain about the instrumental errors with the help of some examples. In the work of calibrating or standardizing the scale of Celsius thermometer, the graduations or marking are done in improper way. What will happen? It will arise an error. Instead of reading 100 degrees Celsius, it may read 104 degrees Celsius at the boiling point of water at HTP. This error is instrumental error. What is HTP? HTP stands for standard temperature and pressure. Second example is error occurred in measurement of length of an object by using vernier calipers if it has not designed perfectly. You have to know that vernier calipers have two scales. First scale is main scale and second one is vernier scale. It also has two pairs of jaws. First pair is upper jaws and second one is lower jaws. In normal condition, the zeroth division of the two scales must be coincided when its lower jaws are brought in contact with each other. It means no gap made between these lower jaws. Then we can say it has no instrumental error. If the zeroth divisions of two scales are not coincided, then it is said to be having instrumental error. And third one is very simple one. If you are going to measure length of a table using a meter scale whose a little portion of one end was broken, you cannot do the proper measurement. Suppose broken piece of about 2.5 centimeter in its length, you will get the result more far from the real value. That is 2.5 centimeters will be the increment as compared to the ordinary measurement. This error is the instrumental error. You should remember that the errors occurred in these instruments such as vernier calipers, screw gauge, spirometers, etc. due to their imperfect designs are the examples of instrumental errors, which are the zero errors. Let me examine the second kind of systematic errors, which occurs due to the imperfection in experimental technique or procedure. If the technique is not accurate and due to the external conditions such as change in temperature, humidity, wind velocity, etc. during experiment, it can affect the measurements systematically. For example, measurement of temperature of human body by placing thermometer under armpit results in lower temperature than actual value. It is due to the imperfection of the technique used for temperature measurement. So, this kind of thermometer may be replaced by a digital thermometer to minimize this type of error or to get more accurate value. See the picture. A car is moving in opposite direction of wind blow. Measurement of engine thrust of this vehicle during the opposite directional blow of heavy wind will give value which is more different from the measured value done in case of no and same directional winds. Because of this imperfection of the experimental technique, this kind of error is occurred. And let me see the third kind of systematic errors. They are personal errors, which occurs due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions, etc. For example, if you by habit always hold your head a bit too far to the right while taking reading by the position of a needle on the scale upon an object whose measurement is too made, it will occur an error due to the parallax. Here, the needle is some distance away from the object whose measurement is to be taken and not viewed from the right position or angle. So this error, which is called the parallax error. On next, I am going to discuss on what are the different methods to minimize the systematic errors. There are different steps. There are some methods by which we can minimize the systematic errors. The first one is taking proper instrument and calibrating it properly. Second one is by improving experimental techniques or procedures. Third one is by improving experimental conditions and maintaining standard of instrument to reduce the systematic errors. That is, experimenting under proper atmospheric conditions and techniques. And last one is removing human bias as far as possible. For a given setup, these errors may be estimated to a certain extent and the necessary corrections may be applied to the readings. On next, second kind of arrays, they are the random arrays to be under the discussion now. What are the random arrays? What are the causes of occurring this kind of errors? These errors occur not regularly and also not orderly. That means they are random with respect to sign and size. Sometimes the measured values may be changing, that is, it may be either increasing or decreasing, and also their signs may be either positive or negative, but they are irregularly occurring. This can arise due to random and unpredictable fluctuations in experimental conditions. Example, unpredictable fluctuations in temperature, voltage supply, mechanical vibrations of experimental setup, etc. Personal unbiased errors by the observer taking readings, etc. For example, when the same person repeats the same observation of an experiment, it is very likely that he or she may get different readings every time. This kind of errors are called the random errors. To get clear picture of random errors, I will give you one example. In 10th grade class, you have studied Ohm's law and its experiment. During the experiment of Ohm's law, voltage fluctuation or variation of electric current due to its heating effect happened, which caused due to heating of the connected copper wire when the apparatus is not properly handled, that is, not opening the circuit when there is not taking observation or reading or it is not in use, causes random error in your result. Now let me think about one kind of errors. It is the least count error. You know about least count of an instrument. Can you say about it? The least count of an instrument means the smallest measurement which can be made accurately with the help of the instrument. Least count error is the error associated with resolution or least count of an instrument. How can minimize this error? Least count errors can be minimized by using instruments of higher precision or resolution, and also improving experimental techniques. For example, if you are going to take several readings of a measurement and then taking its arithmetic means, whereby you can minimize the least count error. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers properly by today itself. One important notice is that CBSE has shortened your syllabus due to the present COVID-19 situation. So, you have to notice the updated syllabus which is given in website. Okay, thank you. Have a nice day.